full power dyno pulls and all the oil pressure in the world. Let's go all in at World TimeAttack 2018. So let's first do a quick rewind for you new guys to this series. 2017 engine was assembled, pretty much ready for World TimeAttack, but the PR Tech team was not happy with the oil pressure amount, and ended up swapping over to their previous engine, which was also actually powerful enough to break the drivetrain. So yeah, kind of bad, but kind of good. Last year, a little bit maybe. But 2018, so they, did lots of development work on the car there. Did track testing with active damping adjustment system, and getting that too, and getting the bump stops adjusted on the car to prevent oscillations. Ended up having some drivetrain issues, but that's got some testing done with that end. For the Thor engine then. They did some, not redesign actually, but some specification changes that we will look at a little bit. So they went with the undersize bearing size on the both on the connecting rod big end and the main bearings, and reground the crankshaft to that size to fit that size with a smaller bearing clearance specification. And that of course immediately helped with the oil pressure, and they now had all the oil pressure they could possibly want. So with that new oil pressure amount, it was dyno time. So they were running the engine multiple times on the dyno there, mapping the engine of course for the first time to a maximum RPM, full boost pressure. And building boost really early in the curve, but they were still the power really wasn't there, and that was due to the turbocharger selections. They were running two really small turbos, but those had a much too small turbine section for our Thor engine really. So when you end up needing boost pressure from the compressor side, that of course needs power from the turbine, but if you have a turbine that is very, very small, then you end up needing a lot of back pressure to get that power from the turbine wheel. And if that pressure on the exhaust side is higher than the boost pressure you require for that power level, then you have very bad exhaust pressure, or exhaust manifold pressure to intake manifold pressure, and that starts negatively influencing engine behavior. And so they were running into this problem, and this was couple of weeks before the race again. Of course, nothing helps progress as much as a deadline or as a closely approaching deadline even. So they were in a problem with the turbocharger, and there really wasn't any better turbocharger available at that time. So this was in we're back in 2018 now, so the new smaller size turbochargers weren't available back then yet. They basically had to go over to a single turbo, but again, because it's racing and they have high downforce, mass is very, very important. So going with off-the-shelf GTX5533 size turbo, or the equivalent from Borg Warner or something like that, means those are very heavy, 30 kilos for just the turbo. So that's just, way too much. And they were looking around at different options, and of course, they needed to find something that was in the shelf directly, so that they could build an exhaust manifold around that and get everything, dyno tuned and everything ready for the race. So not much time, and so they ended up settling on getting a GTX 4202R, I believe that is. It's a slightly older model turbo, but very good design and stuff like that. I looked at the maps for that, and I wasn't really happy with the turbine section. I still thought it was way too small for the Thor engine, but still an upgrade from the really small twin turbos they had previously. So that was positive at least. new turbocharger size. They quickly put together a new exhaust manifold. I mean, the guys over at PRTech are absolutely fantastic with that. So a huge effort for them to switch that over very quickly and get everything up and running. So really nice. But yeah, put that back on the dyno. Much improved, so they were able to make much more power, but they were still running into the issue of the exhaust back pressure being too high, and they were really reasonably limited on the power. I believe on the dyno rollers they were only doing like 800 or 900 horsepower or something like that, so like way too low power for that engine. But I mean, yeah, I mean, it was a big improvement since last year. So yeah, off to the racetrack. Really, I think that was about a week or something like that before the actual race. So getting to the track, first of all, increased the power output from the engine by quite significantly. So they were making much more power actually than what they were on the dyno. And yeah, that's of course because the power level is so high that the amount of exhaust gas is being produced and intake air ingested into the engine so high that the airflow in the dyno room was limiting that. So you had like a exhaust gas recirculation inside of the dyno room, and that really heavily zaps your engine power. So they had to adjust the VE maps quite significantly at the racetrack. But of course, yeah, that's something they have the sensors and everything on the engine to be able to look at that and do adjustments afterwards. So no problem with that. And also, yeah, having the inlet at the front of the car, and yeah, running up to I believe they were running up to 260, 270 kilometers per hour, something like that on the straights. So you have some amount of, I mean, not huge amounts, but yeah, the ram pressure helps, especially on the inlet to the turbocharger, because the compressor map really cares about pressure ratio. So if you can increase the inlet pressure a little bit, your exit pressure from the compressor housing is going to go up quite significantly, and that of course helps the pressure ratio from the intake to exhaust manifold also, and that also of course helps the volumetric efficiency of the engine when you're running racing spec camshaft timing. So with some overlap, and the opening time is of course also optimized for a well-tuned racing engine. I think they didn't even get a full lap out of that testing session then, and yeah, they ended up having pressure leakage issues, so the cylinder pressure leaking into the cooling system, which is a sign of course of the head gasket sealing not working, or there being some other like major fault with the engine. And yeah, at the time when I heard that, I was really surprised about that, because the head gasket sealing was something that I was super confident that is definitely going to work on the engine. Of course, with the temperature things, you're never really sure, but yeah, then I heard feedback that the cylinder liners were being pushed into the block, which was really puzzling, and I couldn't like figure out what was going on with that, because there shouldn't really be like any force being applied. I was thinking like, are the like pistons partly seizing on the cylinder liner or something, and that is pulling them down? But that would seem like really strange, because the forces would be so high that would definitely do damage to something, and you can't like just restart the engine and it will run fine after an event like that. So that was super puzzling. But yeah, I mean, that was basically the sort of pre-knowledge we had, and yeah, we packed our stuff together here in Finland and headed over to Sydney Motorsport Park over in Australia to both go to the event and see if we could help with everything, of course. When we were heading over to Sydney, the PRTech team, I think they redecked the block surface, and what else did they do? Put in a new head gasket, of course, and checked that the surface on the head was flat, and yeah, remounted that. I think that was on Yeah, they had one outing, on Thursday. So the race is on Friday and Saturday, and the Thursday before that, they went out on the track and yeah, tried to see if it would work better this time. And yeah, they got like half a flying lap or something like that, and they had the same problem again, and it had to come in. So this was really bad situation. And yeah, I spoke with Rod. I believe we arrived on Thursday in Sydney or something like that, and we were like, yeah, drove over to our Airbnb place, dropped off our stuff there, and yeah, messaged with Rod like, yeah, it's looking really bad. Like it's yeah, they're having problems with the engine and with the head gaskets and cylinders moving, and it looks like they're probably not going to be able to compete at all at World TimeAttack. So that was like, yeah, really concerning, and it's still like super surprising because the head gasket sealing was one of the things that we hadn't cut corners with. We knew, like, we had like done the calculations on that, and those should be like absolutely world-class head gasket sealing. So that was like really strange. Like how could we have missed something, or was there something strange going on? Like I couldn't really understand what was happening, because there was like no real reason other than there being some issue with the head gasket or something. But yeah, this was of course something that one part that we hadn't seen at all. So this was again to save time back in 2017. So Rod had sourced the head gasket from a head gasket specialist manufacturer, and we had never seen those. But I mean, yeah, the gasket shouldn't be that difficult, so couldn't understand like what was really going on. But yeah, we headed over to the racetrack anyway, and we had to set up our booth there, and yeah, immediately headed into the RP968 booth to yeah, see what was going on with the engine and if we could help it anyway. So at the track, looking at the engine, they had yeah, already pulled the head off, of course, because the failure earlier that day, and yeah, we're looking at the cylinders, and yeah, we came over and looked at it also. So all of the 4 cylinders. So there are these separate cylinder liners, or I mean, this is a blank for that, so it's much heavier and thicker and yeah, bigger than what is in the actual engine. But yeah, those were all pushed into the to the engine block by about exactly the same amount. I mean, there were some small differences there, but like very close to the same amount. Looking at that, like, this seems really strange. I mean, there's like really no other explanation for that than that the head gasket has to have some kind of step around the cylinders. So let me just show you that. Let me get some gloves going. Yeah, this is what the ladies definitely love. But yeah, these gloves are very useful for yeah, engine stuff also, so that you don't spend lots of time cleaning your hands when you touch these parts. So yeah, time savings tip. Yeah, so these so this is a MLS gasket, and not of course from our Thor engine, but this is something we just happen to have over in our shelf, so I can show you guys what I'm talking about. So we have, so this gasket is consists of, let me just check that you guys can see this. Yeah, I think you can. Yeah, so we have multiple layers of varying thickness steel with this coating in between the layers to provide sealing, and then there are so these are not like flat, but they're pressed into these sort of wave shapes to allow for some kind of thermal expansion differences and still seal properly. Yeah, so this gasket actually doesn't have that, but I can show you guys what was going on. So we looked at the gaskets and pulled one of the old gaskets out, and this so apparently what is typically done with aftermarket MLS gaskets, which I was completely unfamiliar with at the time, is that they quite often do this like extra thickness around the cylinder, and they do that by using one of these layers has a fold so that it has like double material thickness just around the cylinder, but not around the rest of this around the rest of this gasket at all. So that like extra fold there creates a thicker surface right around the cylinder, and this was something I had calculated yeah, previously when we were arriving there, because I thought that this was probably like one of the only possibilities for that failure would be if the head gasket is somehow not distributing the clamping force properly on the top surface of the engine block and between the cylinder liners. And yeah, so if we look at a cylinder liner like this, and again, I mean, this is a blank, so this is much larger than the actual component. So I mean, we use blanks to save time and provide sort of development and those opportunities, so we can make them different each time, and yeah, do that very quickly. But yeah, so this extra step around the cylinder bore was creating basically, so the clamping force from the head bolts was being distributed like by a huge portion right on the cylinder liner. And actually, you probably can see from this, so this has a really small step here on the side. I mean, this is, again, the dimensions are wrong, but the sort of step size is kind of sort of representative. So we have this really small step here, and I calculated, yeah, like the clamping force from the head bolts is creating probably, I mean, if it's being distributed mostly on the cylinder liners, that's creating a pressure on this lip here that is above the material strength, and especially the material strength at higher temperatures. So with aluminum alloys, you have strength reduction when you go up in temperature. So at room temperature, you have a higher strength in the aluminum material than what you will have at around sort of 80 to 110 degrees sort of a racing temperature. And yeah, this was then at higher temperatures and sort of a sustained power output. So when the cylinders are getting as warm as possible, that was allowing the head gasket to press the liners into the block. And yeah, so we were on Thursday evening, and I mean, I was reasonably sure that this was the cause of this, and I mean, there was every reason to believe that. But yeah, it's still like always a question mark, because you're just really guessing or trying to do, of course, educated guesses, but I mean, still guesses nonetheless, because you don't have time to figure out absolutely everything. But yeah, as Richard would say, that like the first task, if you have a problem, is figuring out how much time do you have to solve the problem. And yeah, then you can figure out, okay, like we have these amounts of options on what things we have enough time to do before the race. And yeah, I mean, they wanted to ideally deck the block, and I was like, well, I mean, yeah, we don't really have time for that. And I mean, they agreed also. There wasn't time to deck the block, and they had tried that previously from the issue they had 1 week earlier, and that hadn't really helped. So yeah, we're basically at a situation where you could not deck the block, but we're looking at the step on the head gasket, like, okay, the step on the head gasket, so the extra step around the cylinder is slightly taller than by the amount that the cylinders had been pressed into the block. So like, okay, let's just slap on a fresh head gasket, put the head back on, like, don't deck anything, don't touch anything, and it should probably work fine. I mean, just torque the head bolts down, and then yeah, do heat cycle, and then retorque the bolts again, and then another heat cycle and retorque those. So these are the kind of tricks you use for copper gaskets, typically, where you have like a really sort of non-conforming or head gasket that has very low conformity, so to say, so that when everything heat cycles and like moves by a tiny bit, then you need to retorque the bolts to like re-even out the clamping pressure, so that you don't have like low areas with low clamping pressure where you're going to have leakage issues, because there's not enough force clamping the gasket together. And yeah, that's basically what we came up with. And so they also had some really good equipment there also. So they had a system to preheat the engine before startup. And yeah, that's how, of course, allows running tighter bearing clearances, for instance, which is what they wanted to run, and they didn't want to take risks of those small bearing clearances, like causing the bearings to clamp to the crankshaft instead of the engine housing or the connecting rod. And spin those bearings, so they wanted to preheat the engine. And I was like, okay, I mean, definitely, we have very little time. There's no time to test at all. I mean, the next session is on Friday morning, and that's already the race. So let's just keep the engine heater connected during the whole race event, so that we reduce the amount of heat cyclings by as much as possible. I mean, after the head gaskets have been or the head bolts have been retorqued multiple times. And yeah, that's basically what we were planning on going forward with for the race. And yeah, that was relatively a little amount of work to do, so they will definitely be ready for Friday morning, and actually have some time to sleep in between also, which is really beneficial, because if you run into problems further along the line, then you want to have rested people that can do good decisions quickly, instead of having really tired people that might make some bad decision because of them being super tired. So now with this sort of chewing gum sort of fixed to this actual problem, I mean, the real problem would have been to get head gaskets without that step done, and the block surface to get that flush with the sleeves, but there was no time to do any of that, so yeah, just had to go with what we had. Afterwards, going through stuff, I mean, Rod would say that I'm a positive person, so I always like to sort of guess things sort of on the positive side. So I was, reasonably confident. I would have guessed probably like 80% odds, maybe something like that the engine or the head gasket situation would be like good to go for like close to indefinitely with this solution. So even with like the sleeves indented into the block and these issues, but I mean, I thought that would be really good, because this would be much closer with the stepped head gasket to what I had designed the sort of clamping forces to be distributed with. So I was reasonably happy with that. Rod estimated that I don't remember exactly what he said, but I think it was something like a 50-50 chance that they would be able to do one full lap. So quite a bit of difference there between our sort of evaluations on the situations. So everything between reasonably certain that everything will work fine to like, well, there's a 50-50 chance that we will be able to do one single lap. But yeah, I mean, from last year, or from 2017 last year, Rod was really close to getting the win, and he really wanted that win, and he had been like, from the beginning of the year, like, I mean, this year we're going all in, like it's a win, or like, yeah, we have to put everything towards going to the win. We're not going back to any like old things or anything like that. We need to get everything to work. And yeah, this is, I mean, if it doesn't work, it doesn't work, but we're not going to compromise on the performance, because we really want to do that win. So I mean, that is I think a perfect sort of attitude for racing anyway, and something that we fully support, of course. And yeah, with that good attitude, so we can look at I'll just edit this in later, but looking at the lap times here from the previous years. So in 2014, 15, 16, and yeah, from 17, what sort of time differences between the RP968 and the fastest other car there. So 2017, that B2, so really good solution for or a result for that. They were still a half a second behind, and half a second in circuit racing is really quite a lot. So they had quite a lot of stuff to make up to beat that last year's pole. And of course, I mean, the other teams are definitely improving also, so you can never like figure out, okay, like if the guys did what was it that they did in 2017? So a 120.971 was the winning time from 2017. Like, okay, like how much are they going to improve from that? And then like we need to improve more to be able to first like close the gap, and then like improve further to get ahead of them also. So it's, I mean, it's a big task, of course, always to do that. But first run in the morning on Friday, run a flawless lap. I don't remember exactly what time it was, but yeah, came in after the lap, engine was still running, everything was good. So really a positive outcome for that. And car was complete, and they were like starting to do setup things and figuring out wet tires to do, and the weather conditions were not really ideal in 2018. So rain, lots of wind, and they were weather forecast was basically rain for both Friday and Saturday. So that was going to be quite difficult to improve on the lap times from the previous years. Of course, the winner of the event is still the guy with the fastest lap time that event, or the fastest team. But of course, you always want to improve on previous year's time, and that was something that Rod was always looking at, is to get the absolute lap record at Sydney Motorsport Parks. Yeah, the end of what was it? End of Friday. Yeah, I think the RP team was maybe in the lead. I'm not sure, but it was, if I remember correctly, it was reasonably close after Friday. So everything was still open for Saturday. I think the weather forecast for Saturday was that it was going to be slightly dry in the morning and then dry in the afternoon also for the superLap, I think. If I remember correctly. I mean, this is a little bit shady, of course, always going back that many years, but yeah, so we're definitely looking forward to Saturday, but Friday was already really, really nice. We're at a provisional P1 position with the Thor engine in the RP968. It was still running, everything was going great. Has some really nice onboard footage, data logging, and we're sort of looking at what kind of power outputs they were doing. So they were doing much higher power outputs than in the dyno, again because of not having exhaust gas recirculation to the inlet of the engine, and also the ram air pressure helping with the the pressure ratio, so the intake manifold pressure to exhaust pressure ratio, and things were looking good. So Friday, or not Friday, we're on Saturday. So Saturday morning, first session is slightly dry. Let's go on board with that video, or shortly now. Coming up here to the last corner to start the start of the straight here. Pulling significantly higher speeds than previous year, topping out there at 266 kilometers per hour and going absolutely flat through turn 1. Really impressive. And Martin Mower doing a really good job here with the car also, considering like how many laps they had been able to do previously. I mean, just half laps and stuff like that. He's really, really hard on it. Here, definitely missed the apex on that corner. I think that's turn 8, if I remember correctly. So just were able to carry so much more speed through turn 7, and really, really a lot of power from turn 7 to turn 8. So just missed the braking a little bit in turn 8. Yeah, coming out on this, already coming out on the straight here now to finish the lap. Sweet new lap record, and first, cementing the first sub 120 lap time in World TimeAttack history. So really, really nice. Yeah, I think they had. I saw in the comments on this on YouTube that someone had timed the in-lap from this video. So yeah, I mean, of course I'll put a link to this video on YouTube so you guys can look at this without my commentary like messing up your viewing experience. But yeah, I had some guy comment on this that the sort of in-lap was faster than what they were able to do with their race car on Sydney Motorsport Park. So quite funny there. And yeah, it was just awesome to be up there on the pit stand, seeing the times on the screens there. rushing down with Rod and the rest of the team into the pit garage there to be there when Barton pulls into the garage. And yeah, with the tire situation also, so I mean these are street tires that they're running. So these street tires, once you go flat on the straight and through turn 1, the tire takes so much beating because of the huge amount of downforce on those cars that you can't really sort of do more than one lap, or it's really dangerous to start doing more than one lap on them. So of course we knew that, okay, they work, so the Barton has to come into the pits afterwards. So yeah, we're heading down there to greet him. And yeah, Barton of course heard this over the radio also, his lap times, so super excited about being the first sub 120 time attack there. This is a really big improvement also from previous years. Yeah, you can see the team here super excited. Costa over there also, and yeah, of course the video crew also from a World TimeAttack. So yeah, Bart, that is so awesome. This is like, yeah, probably one of the best moments for the 2018 effort. Yeah, if we jump over and look at the lap time chart here, so yeah, this is with the lap time now with the RP968 with the Thor engine. So and again, I mean, equal importance, not just the added power of the Thor engine. I mean, there are multiple cars running close to the same amount of power, but the point here is that we can make that power while still having a very light engine and still having very good engine response also. So you can sort of tune the engine at the racetrack without having to have like anti-lag or nitro boosting or something like that to get sort of the turbo lag filled in, because you need to run a super high boost or something like that. But this runs very moderate boost and has very good power off boost, and still a very lightweight overall package. So that is as important, if not more important, than the actual power output from that engine. But yeah, so you can see here, so the fastest other car, for instance, the time increased in 2018. That's of course not because the cars are actually slower, but because the conditions were not ideal there at all in 2018. So the track was still damp, and yeah, the grip was definitely not the best possible there. But still, they had a huge improvement in lap time here with the RP968, and that is especially impressive, yeah, considering that the fastest other cars, so that's the MCA suspensions Hammerhead car, they could, yeah, I think they were, how much is that actually? That they were 0.4 of a second slower in 2018 than 2017. So yeah, the RP968, yeah, with Thor power there now being that much faster is insanely impressive. I mean, you have to go back a lot of years in a World TimeAttack before you see this large of a gap, so that was really impressive. And of course, I mean, a huge part of that is also, I mean, yeah, how good the PR Tech team was. I mean, they did a lot of improvements to the mechanical aspects of the car, reduced weight of the car also. Yeah, the aerodynamics were also improved from previous years. So I mean, the overall aero package was the same, but they did lots of sort of small improvements that they didn't have time to do the previous years. The previous year that like, yeah, helps manage the flow in areas, and these are with aerodynamic stuff so important. Like, if you have one area where the airflow isn't working proper, like as you sort of designed it to, and that is a critical sort of area, then that can end up reducing the amount of downforce you're producing by a big amount. So I think there were like over 10% increase in downforce. So that is very important for lap times, of course, also. And yeah, overall really excited about that, and super performance. But yeah, this was just the morning session on Saturday. So yeah, the weather forecast was still, yeah, looking like it was going to be rain sort of midday, but then it was probably going to be dry for superLap. We're looking like, okay, like this is definitely a possibility to improve, because I mean, yeah, the team also saw that the conditions were not ideal, so there was definitely margin to improve that lap time. And I mean, you can always better the setup also. And yeah, Barton missed that one apex, and probably not ideal speed through all the other corners also. I mean, still awesome performance with that little amount of testing and laps to be able to pull that off. But yeah, everyone was looking forward to the final superLap shootout. But yeah, being a super untested things and yeah, everything going relatively smoothly. I mean, there had been so on Friday there had been some electrical issues with the engine system. So the what is it? They had both wiring issues where they moved the wiring around a little bit to not so that the ignition system would not cause interference, and they also had triggering issues with the crank trigger, I believe, or something like that. I think that the moving the wires further away from each other helped with that, and I think they had an ignition coil that they switched out also. I mean, these sort of small things that you immediately fix when you can test stuff, but because they hadn't been able to test anything previously, I mean, this was the stuff that they need to figure out at the track. But again, a really good team and really professional, and they were able to do that without losing significant time or anything like that. So really good to be able to solve those. But now on Saturday, yeah, we were starting to run into some problems there. So the engine was not. I don't remember what the actual was. If Barton maybe commented that the engine started to sound a little bit differently or something. But yeah, on Saturday afternoon, something like that, I think they had a new misfire. So we're looking like, okay, do we have like another problem with the electronics that we need to solve or something like that? But yeah, no, that was a mechanical problem with the engine this time. So the actual problem and the info we got at the track was that I think one of the exhaust valves was not closing all the way. So I said, okay, we might have like the valve seat might have been damaged or dropped slightly or something like that. That was keeping the sort of valve lower down than what it was supposed to seat at, or the valve might be bent, or could have had some piston damage that has caused damage to the valve or something like that, or the valve could be seized in the valve guide, or there could have been some amount of other failures. And theoretically, there would have been enough time to put a spare head or spare engine in the car, but again, because there had been so little testing, that the spare engine hadn't been assembled yet. So basically, it had no spares, or I mean, major spare components, but not like this type of a sort of complete ready to bolt in cylinder head or anything like this. So basically, we're forced to sit out the superLap and couldn't take part in that. So that was kind of a bummer, and we knew that, okay, the engine problems that we need to solve. But I mean, still, for being the first time that the engine made a complete lap at the track, we're able to pull off a win. I mean, of course, it's not just the engine, but the car also. But of course, the car would definitely not be that fast without that engine also. I mean, motorsports are equal amounts. Engine, the motor part, the overall car, the driver, the whole team, and I mean, lots of things go into making a really fast lap. But I mean, thinking about that with the sort of knowledge of the actual event and what had happened with the engine and especially the engine dissection. So this episode is already too long, so we're going to go through some of the details on the engine and what we had looked at that in next episode. So definitely stay tuned for that. That had been relatively close in 2018. So on Thursday evening, they were reasonably sure that they're not going to be able to run at the event at all. But they ended up, doing a new TimeAttack lap record there, being very, very close to the absolute lap record at the racetrack. And taking home P1 for the first time, like smiles all around, and car was still nice, no like major destruction or anything like that on the engine for the that was the sort of a first running for that. So hugely happy with everything that had gone on there, but it had been relatively close, but we were lucky to be able to pull off a P1 from that. But yeah, so to wrap up 2018, P1, so first World Championship for a complete Elmer Racing Thor engine. So any Elmer Racing complete engine for that matter. This was the first one, so super happy, and I mean really sort of lifting our whole company profile, how sort of confident we are talking to other people on what we can do and what we can't do, and being able to show people, okay, I mean this was the first outing of the engine. I mean it had been run on the dyno, but no circuit testing, anything like that at all. Just run the first full lap was at the actual event and won that event. So one single race with the engine and one World Championship. So it has a 100% win record at the end of 2018. I mean that's a record you really can't beat. So super happy about that. So that was it for this episode, guys. I'm Oscar from Elmer Racing, and this was episode 4 of our Thor the Story. We were all in at World TimeAttack 2018. The era of Thor has started. And next week we're going to World TimeAttack 2019. Are we going to pull off another win? Are the other competitors going to improve further? What's going to happen? That episode is coming out 26/6/2020, so June 26th. Stay tuned for that one, guys. And we'll roll some media stuff here for you guys to watch at the end. Bye.